Good evening, Vananda. Good evening, Vananda.
Good evening, sir.
Good evening, sir.
Is my voice audible?
Yes, sir.
Okay. Is this board visible to you? Is this board visible to you, please? Is this visible to you?
సార్ కొంచెం
Yes.
దగ్గర పెట్టండి సార్.
Okay. Is it okay now?
Okay, sir.
ఓకే సార్.
Right. So this is one of the important topic. Some questions we are expecting from the D block elements. So already P block is over. This time we don't have S block and we have P block. It was over. We discuss about the D block elements. Okay. So this is Dr. Kandala Satyanarayana, Assistant Professor Chemistry, degree college, Hanamkonda. Okay. Right. So what are D block elements?
Yes, sir.
Define. Any one of you please define D block elements.
Differentiating electron enters into D block, sir.
Okay. Please define D block elements.
Differentiating electron enters into D block, sir.
Right, that's all. So elements in which the last electron or the differentiating electron enters the n-1 d subshell are called D block elements. This is one important question. Question number 2 or point number 2. These D block elements are also called transitional elements. D block elements also called transitional elements. So what are transitional elements? What are transitional elements? What is transition? Transition is a change. If you observe the periodic table, the total elements are classified into 4 blocks. That is S block, P block. In between these two, B block. Of course, one more A block. So these are the 4 blocks in periodic table. So these D block elements are present in between the S block and P block, whereas S block elements are more metallic in nature. While moving from left to right, the metallic character is decreasing. If you move to P block, you will be able to see the non-metallic character. So the change from metallic character through metallic character to non-metallic character is not direct. It will be happened through the middle elements. The middle elements are D block elements. So the transition from metallic nature to non-metallic happens through these elements. Gradually the metallic nature is decreasing and this becomes non-metallic. Therefore the transition, these elements, the D block elements which are in between the S and P block are called transition elements. Okay? Right. Next important point. The another important point or definition for the transition element, very important. The D block elements in which the n-1 d subshell, whether in atomic state or significant ionic state, either in the atomic state or in its compound or ionic state, it should have incompletely filled D subshell. So those elements are called transition elements. For example, if you take the 12th group or second B group, we will discuss. So second B group or 12th group, that is what? Zinc, cadmium, mercury, this group. So you take zinc. So what is the configuration of zinc? Zinc electronic configuration is argon 4s2 3d10. So you see the D shell, this is N shell, N minus 1 D shell is completely filled. Even if you take its compound, for example, if you take zinc chloride, what is the oxidation state of zinc here? The zinc oxidation state is +2. Only 2 electrons are lost from the outer cell or nth cell, but still in zinc ionic form also it is a completely filled shell. It has no unpaired electrons. So therefore, so this group is, though it belongs to D block, it is not considered as transition element. So what are transition elements? The D block elements in which either in the atomic state or in a significant ionic state, it should have incompletely filled D subshell, N minus 1 D subshell. If you see the second B group or 12th group elements like zinc, cadmium, mercury, either in the atomic state or in the significant ionic state, it does not have the unpaired D electrons. So therefore, this group elements are not considered as transitional elements. Of course, it is a D block element. Right. One more significant statement which is commonly asking as a general statement, all transitional elements
D block elements.
are D block. All transitional elements belongs to which block?
D block. But all non D block belongs to transitions.
Right. Vice versa is not. Vice versa is not. Transition elements are D block. All D block are not transitional. Just so far we made a statement. So D block elements means the elements in which the differentiating electrons in the N-1 D subshell are the D block elements. Transition elements should have incompletely filled N-1 D subshell. So therefore, if you see the zinc group, though they are the D block elements, they are not transition element because they may give a multiple choice question on this. Transition elements are D block elements. They give 4 statements. So they will have incompletely filled D subshell, they will completely fill D subshell, they completely filled outer shell, they completely filled D and F shells. Like that, they may give different options. We should choose the appropriate option. So this is about a general introduction about the transition elements and D block elements. So here in the D block, the main points what we will discuss is electronic configuration of D block elements. Electronic configuration. So questions are expected from this also, but we focus mainly on the 3D series. Little extent 4D and 5D. We little extent on 6D also. Very, very little extent. So, what is the general electronic configuration of D block elements? General outer electronic configuration of D block elements? Any one of you?
4s2 3d.
Amma? 4s2?
3D 1 to 14.
Right. Okay. So you are telling for the 3D series. Very nice. So the general electronic configuration for any D block. So you know D block elements. What is the position of the D block
1 to 9.
elements?
1 to 9.
Position. They are in between the S and P block. Number 1. Number 2. Where it starts. So the D block are there are 4 series. 4 completely 3D series, 4D series, 5D series, and 6D series. Right. So these are the 4 series of the D block elements, 40 elements. Okay. Where it starts? 4D starts. Where it starts? In which period it is available? 3D series?
Scandium to zinc.
Yeah.
After calcium. Okay. We have scandium like that. First period is what? Hydrogen. Second period is lithium. Third period is sodium. Fourth period is potassium. Of course, the secondary period magnesium and calcium. So therefore, the D series start in which period? 1, 2, 3, 4. Which period? This is 1 once or twice if this question is asked. The 3D
What's the
series
period?
exist in which period? The 3D series elements exist in the
What's the period?
fourth period. Of course, the remaining are in the subsequent periods, that is fifth, sixth, and seventh period. So therefore, the total D black elements are generally studied in four completely filled series. One is the 3D series, or first transitional series, 4D, or second transitional elements, 5D, third transitional elements, 6D, seven transitional elements. The 3D starts, or the D black element starts from the fourth period onwards. Right. Now, electronic configuration of the D black elements. So the general electronic configuration of the D black elements is N-1, D 1 to 10, NS 1 to 2. Sometimes it may 0 to 2 also. Majority of the cases they will give this option. Rarely they may give, because like palladium, such elements they may have. Okay. So generally this is the configuration. The general electronic configuration of the D black elements are N-1, D 1 to 10, NS 1 to 2. So this is for the D black. What about transition elements electronic configuration?
1 to 9.
Amma?
N-1 D power 1 to 9.
1 to 9. 1 to 9. MS 1 to 2. So among the following configurations, the configuration of transition elements, they will give this one, and they may add the P, and they may add a S and P also. So the right answer is N-1, D 1 to 9 to NS 1 to 2. Right. Next. So some more important questions from the electronic configuration. So generally they focus on 3D series. Electronic configuration of 3D series. What are the 3D series elements? Scandium, titanium,
Vanadium.
Vanadium, Satyanarayana,
Series.
cobalt, copper. Is it visible? All the area? Right. So, because next we are going to discuss about variable valence or variable oxidation state. So that is also very important area. So to understand the variable oxidation state or variable valency, one should be familiar with the electronic configuration. Of course, I think everyone is familiar with the electronic configuration as 2, 22, 23, 24, 25, 26, 27, 28, 29, 30. Just right. What is the configuration of scandium? For every 3 elements, there will be argon, 4s2. Now 3d1. I am not writing the 4s2 again. Please feel that 4s2 is there. Everywhere I don't write. Otherwise I will write 3d2.
4s2. 3d3.
3d3.
4s2.
3d4. 4s2.
3D5,
Of course,
4S2,
3d6. And keeping S aside, 3d7, 3d8. Here what? Here 4s2,
and 4S1.
3d9, 4s2. This is the generally expected, and of course, of course, some of you are telling that, sir, you've gone wrong here, where chromium. So the expected configuration is 4s2, 3d, sorry, 3d. But the observed one is 4s1, 3d. This is very important. Frequently questions may be posed from this area. And here also, sorry, copper. This is also 4s1, 3d10. Right. So you know the electronic configuration of all the 3D series elements. While moving from left to right, there is increasing one atomic number, and also each electron is increasing the d subshell. There is no change in the, if you observe the electronic configuration of this one, this is N-1, D 1 to 10, NS 1 to 2, This you can write as 3D 1 to 10,
NS 1 to 2.
1 to 2. This is the electronic configuration of
D
3D
block
series.
element.
So only for this particular group, where this is third group, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th. This is the IUPAC nomenclature. Otherwise, this is third week, 4th, 5th, 6th, 7th, 8th. These are all comes under 8th. This is first B and this is what? Second B group. As per the old convention, Roman letter, this is third B, fourth B, fifth, sixth, seventh. So these three groups comes under the 8th group, and the copper group is first B, G group is the second B group. So the question is, the chromium electronic configuration is 3d5 4s1. So this is, how can it explain? How can it explain? So generally this is the configuration, it should have 3d4. Why it is 3d5?
Because the half fill stable.
Stability.
Filled or fully filled. Stable, sir.
The half-filled d subshells, if each d orbital of the d subshell occupies one electron, it gets extra stability compared to this particular configuration. Therefore, one of the electron from 4s it transfer to 3d. So therefore, to get this stability, so the system adjusts like this, and it is the electronic configuration. Okay, right. Same the case in the case of the copper also. So what is the answer here? Instead of 4s to d9, the observed one is 4s1 d10. Here also one of the s electrons moves to d. Here the completely filled configuration gives extra stability to the copper. And here the energy difference between 3d and 4s is very less. Almost are very close, 3d and 4s. Therefore, there is no energy parameters, much energy parameters required for the movement or transfer of the electrons from 4s to 3d. Therefore, the system itself adjusts the electron from 4s to 3d to get the stability. In the case of chromium and copper. So the two elements which are different electron configuration than the normal from the 3D series. Which elements? Scandium titanium, vanadium chromium, chromium copper, copper zinc. What is the answer?
Chromium copper.
Chromium coppers.
Chromium copper. Right. Okay. Now the important area. So characteristic properties of D black elements. Next topic. What we have? Characteristic properties of D black elements. What are characteristics property of D black elements compared to the P black elements? These D black elements have some more significant properties. Those properties are said to be the characteristic properties of only the D black elements. So what are the characteristics properties of D black elements? You know, what are the characteristics properties of D black elements? Of course, these are Amma. What are the characteristic properties?
Boiling point and melting point, sir.
Okay, those are general for any metal we have the melting point and boiling point. Any metal will have the luster. Okay, any metal will have some density. Compared to the S block and other P block metals, what is the characteristic properties of D block elements is they show the Amma,
Color properties, sir.
variable oxidation state. Okay.
Metallic nature, sir.
Amma,
Metallic nature.
okay, metallic nature or general property of any metal. S black element will have
Complex formation.
Amma,
Complex compound formation.
complex compounds formation. Very nice. complex compound formation. What next? Color property. Okay. What next? Magnetic property.
Catalyst, sir. Catalyst.
Magnetic property. What next?
Catalytic nature, sir. Catalyst.
Catalytic property. Catalytic property. Of course, they may form interstitial compounds. All these. So, for our discussion purpose, we will only discuss about these characteristics properties of the D black elements. One is the variable oxidation state. Later on, we may discuss complex compound formation, the color properties of these compounds, magnetic
Electric
property,
conductivity.
catalytical property. Please, is it okay?
Electric conductivity.
Amma?
Electrical conductivity, sir.
Electrical conductivity. Of course, these are the metals. They have a good conductors of heat and electricity. Among all the available metals, the best conductor of electricity is which one?
Silver.
Among all the elements.
Silver, sir.
Silver, copper,
Silver.
Silver is the best conductor
copper.
of electricity. Okay.
Sir,
Next, copper. For heat also, silver. Okay.
sir, inert pair effect ఉంటుంది.
Amma?
Inert pair effect.
Inert pair effect we will see in the D black, P black elements. For example, if you see the fourth group elements, what is the common oxidation state in the fourth group? It is +4. The expected is +4, fourth group. While moving from carbon to lead, carbon, silicon, germanium, tin, lead. While
Yes, sir.
moving from carbon to lead, instead of showing the +4 oxidation stability more, it shows the +2 significant oxidation state, more stability in the case of lead. Compared to lead 4, lead 2 compounds are more stable. That can be explained in terms of what? Inert pair effect. What is inert pair effect? While moving down in a group, in the bulk element or the last element or the large element, the participation of NS electrons is decreased. So therefore,
Yes, sir.
when the 2 electrons are not participating in the bonding, that pair is called inert pair effect. Due to the inert pair effect, like fourth group and fifth group, the last element shows not group oxidation state. Instead of group oxidation state, N-2 is the more stable oxidation state. In case of fourth group, 4 - 2, that is +2. In case of fifth, it is fifth -2. In the case of bismuth, +3 is the more stable. So this is what inert pair effect. Okay? Right. Shall we discuss about variable oxidation state? Right. So generally question are what is oxidation state of an element? Oxidation state of an element. Charge appearing an atom or an ion is said to be oxidation state. Okay. So if you take any element, what is oxidation state? Oxidation state is charge appearing in an atom or an ion. For example, what is the oxidation state of scandium?
+2 +3
Scandium?
+2 +3.
+3
Scandium means I am asking scandium element, elemental
Plus
state,
one.
atomic state.
Plus
What is
one,
the oxidation state? 0. Okay. What is the oxidation state of hydrogen?
+1.
+1.
Please.
I am not asking
Yes.
on the compound. I am
Zero.
asking chemical state.
0
Okay. What is the oxidation state of silver?
+2.
I am asking again in atomic state only.
0 sir.
अरे प्लस टू
Sorry, sorry. Okay, so oxidation state means what? It is the charge appearing in an atom. For example, it is scandium atom, hydrogen atom, silver atom, gold atom, any atom, its charge in atomic stage, the charge appearing in an atom is zero because hydrogen atomic number is one proton and one electron. The net charge appearing on the hydrogen atom is zero. The charge appearing is zero means it is the oxidation state zero. Similarly, silver 47 protons, 47 electrons. The positive charge equal to negative charge. Therefore, it does not show either positive charge or negative charge. Therefore, it is also a zero oxidation state. So what I mean to say is, so
Sir, audio is not audible. Sir,
Andy,
సార్ వినిపిస్తుంది.
yes, sir.
okay na?
Now it's okay, sir.
Okay, is it okay?
Yes,
Right.
sir.
Now let me ask you, what is the oxidation state?
+3 sir. Stable oxidation state +3 sir. Both +2 and +3 sir.
అమ్మా ఒక్క నిమిషం లైన్ లో ఉండండి, ఒక్క నిమిషం లైన్ లో ఉండండి ప్లీజ్, ఓన్లీ 1 minute ప్లీజ్.
ఎవరైనా ఆన్సర్ చెప్పండి. +2 నా +3 నా ఐరన్ ఆక్సిజన్ స్టేట్.
Both
Sorry for
+2 and +3.
interruption. Okay, what is the oxidation state of iron? Please tell me.
+2.
Here 0, here +2, here is +3. So what is the difference here and here? Here iron is in the atomic state. In the atomic state, what is the atomic number? It is 26. 26 protons, 26 electrons. Therefore, it does not show either positive charge or negative charge. Therefore, if take any element in atomic state, its oxidation state is 0. But when you take its compound, if it is metal, while forming the compounds, it loses electrons. So here iron loses 2 electrons. Therefore, the oxidation state is +2. Here iron loses 3 electrons. Therefore, the oxidation state of the iron is +3. So if you are observing the D black element, the beautiful characteristics property of the iron, it's here +2, here +3. Somewhere it also shows +6 oxidation state. So this is what said to be variable oxidation state. Variable oxidation state means it is the ability of an element to exist in different oxidation state in different compounds is the variable oxidation state. The transition elements, the D black element shows variable oxidation state because of its electronic structure. What is the electronic structure of 3D series? What is the electronic structure of 3D series? It is NS122 N-1 D1 to 10. This is very, very important. Unless you know the electronic configuration, it is very difficult to understand the variable oxidation state. Now, so how these transition elements, either 3D or 4D, 5D, 6D, why transition elements are able to show different oxidation states? Please tell me, any one of you, So oxidation state depends on what? Oxidation state depends on what? Electronic configuration. Oxidation state depends on how many number of electrons are involving in the bonding, how many electrons are lost, or how many electrons are shared. So like that. So therefore, electronic configuration of the elements is very, very important to understand the oxidation states, especially to understand the variable valency or variable oxidation state of the d black elements or transition element. One should understand the electronic configuration. If you see the electronic configuration, outer electronic configuration, ns1 to 2, n-1, d1 to 10. So if some elements may have ns1, some elements may have ns2. So therefore, please try to understand, if any of the d black series, if only using these electrons means outer s electrons, not d electrons, involving in the bonding means they will show +1 oxidation state. If only outer ns electrons, they are using ns2 electrons, they will show +2 oxidation state. So are you able to understand, please? So the +1 or +2 oxidation state of the d series or d black elements are only the involvement of electrons from ns. If only one electron involves, if it is +1, if both the two electrons involves, it is the +2. So what about the remaining electronic configurations? Along with these ns electrons, the d black elements may use their n-1d electrons. If ns and n-1d, if both electrons are involving in the bonding, then there are more members. Here 2 electrons from s, 1 from here. What is the oxidation state? 2 electrons from ns. For example,
This one, sir.
whose electronic configuration this one? Please tell me. Whose electronic configuration this one?
Alkyl.
3 plus 3.
4s2 3d1. Whose electronic configuration?
Scandium.
Scandium, sir.
So therefore, what is the expected oxidation state for scandium?
Plus
If
3, sir.
only 2 electrons are involved, scandium can show what type of oxidation state? +2. And along with the s electrons, it's also using the d electrons. Now, totally, how many electrons are involving? 3 electrons. Therefore, when the s electrons and d electrons involves in the bonding, the scandium shows +3 oxidation state. So now tell me, what are the possible oxidation states for the scandium?
+2 +3
What are the possible oxidation state for scandium?
+2
Plus
+3
2 plus 3, sir.
When +2?
And it is 1, sir.
When only outer 4s electrons are involved. When +3?
Both
4s2 3d.
both S and U.
Yes,
Valency
yes, both. అది కొట్టాలన్నా నెంబర్ కొట్టి ఒకసారి నెంబర్ అమ్మ ప్లీజ్ జస్ట్ ఎ మినిట్ 1 minute ప్లీజ్ ఒక్క నిమిషం ఉంటాను. One minute. Okay, ma'am. 8197. జస్ట్ కొంచెం నెట్ ప్రాబ్లమ్స్ ఓకే అమ్మా ఓకే సారీ రైట్ సో Right. Now, please tell me. Possible oxidation states the titanium.
Sir, screen is
Sir,
not.
your voice is not clear, sir.
+3 and +5. +3.
+2, +3, +4. Please see, what is the configuration of titanium?
3D2, 4s2. 3D2, 4s2.
+2. 2 s electrons, 1 d electron, +3. 2 s and 2d, +4. What about the vanadium possible unexpected configuration oxidation states?
Sir, voice clear.
Is it clear?
Screen కనబడట్లేదు సార్.
సార్ బోర్డు కనిపించట్లేదు.
బోర్డు కనబడట్లేదా?
సార్
అమ్మ బోర్డు
No, sir.
కనిపించట్లేదు.
క్లియర్ గా
No,
లేదు
sir.
సార్.
వాయిస్ కూడా క్లియర్ గా లేదు సార్, అసలు అర్థం అవ్వట్లే.
అయితే అమ్మ ఇప్పుడు నా సెల్ కొంచెం ప్రాబ్లం ఉండే ఆ సారు వెళ్ళిపోయినారు, అదే ప్రాబ్లమ్ తో నేను ఇప్పుడు క్లియర్ అసలు వాయిస్ వినిపించట్లేదు మీకు?
లేదు సార్.
అంటే
బ్రేక్ అవుతుంది సార్, కొంచెం
బ్రేక్ అవుతుంది సార్ వాయిస్.
బ్లింక్ అవుతుందా తల్లి?
బ్రేక్ సార్, బ్రేక్ అవుతుంది.
అది బ్రేక్ అవుతుందా?
ఎస్ సార్, ఎస్ సార్.
కొంచెం కూడా ఫాలో అయ్యి అంటే వాయిస్ అర్థం కావట్లేదా మీకేమి?
నవ్ ఇట్స్ ఓకే సార్.
బోర్డు క్లియర్ లేదు సార్,
Now
అంటే
it's okay,
వాయిస్
sir.
అర్థమవుతుంది సార్.
ప్లీజ్ కంటిన్యూ.
ఇది నా సెల్ కొంచెం ప్రాబ్లం. ఇప్పుడు క్లియర్ గా కనపడుతుందా మీకు? అమ్మా క్లియర్ కనపడట్లేదు తల్లి?
నో సార్.
సో అమ్మా then I should take tomorrow only, ఎందుకంటే my mobile is somewhat problem, therefore I cannot continue in this mobile, and some other mobile is not available at right now. Please, I'm sorry for this. Tomorrow I will continue the class. ఎందుకంటే అమ్మా
ఓకే.
యాక్చువల్లీ ఇది కొంచెం నా మొబైల్ ప్రాబ్లం ఉంది. నేను రేపు ఏదో ఒక టైంలో నేను వేరే సార్ మొబైల్ తీసుకుని రేపు కంటిన్యూ చేస్తా. ప్లీజ్ సారీ ఫర్ డిస్టర్బెన్స్. ఓకే
ఓకే సార్, నో ప్రాబ్లం సార్.
రేపు మళ్ళీ క్లాస్ ఎప్పుడు ఉంటది అనేది షెడ్యూల్ చేస్తామా రేపు? ఓకేనా? ఇవాళ కొంచెం మేడం కూడా ఎలక్ట్రిక్ కెమిస్ట్రీ చెప్పే మేడం కూడా హెల్త్ బాగాలేకుండేను. సో నేను రేపు కంటిన్యూ చేస్తా ఏదో ఒక టైంలో. ప్లీజ్ సారీ ఫర్ దిస్.
ఓకే సార్, నో ప్రాబ్లం.
ఓకే, థ్యాంక్ యూ సార్.
Shall I leave this?
ఓకే సార్.
థ్యాంక్ యూ.
ఓకే, థ్యాంక్ యూ.
Okay. Thank you, Ananda.